Hello everyone, my name is Nisha, pursuing MCA in BTU College, Belgavi, and today my topic is image forgery detection. I'm gonna explain about image forgery detection project, which consists of introduction, project description, literature survey, existing system, proposed system, feasibility study, tools and technology used, and hardware and software requirements, user requirements, software requirement specification, which consists of functional and non-functional requirements, system design, which consists of prescriptive and context diagrams, detailed designs, use case diagram, data flow diagram, diagram, and implementation, which consists of code and auxiliaries. Software testing consists of white and black box testing, and conclusion for future enhancement and appendix bibliography. First, introduction consists of first chapter of project description. With the rapid advancement of digital image editing tool and technologies, I switch with creating sophisticated image forgery has raised concern about the authenticity and trustworthiness of the virtual content. Image forgery detection describes the deliberate manipulation or alteration of image with the intent to the device viewer or mislead the authenticity. The traditional method of detecting image forgeries often rely on manual inspections by forensic experts, which is time-consuming, subjective, and may not be scalable to handle the ever-increasing volume of the digital media. As a result, there is growing demand for automated and dependable method that may precisely identify the forgery images. Particularly, deep learning, machine learning emerged as a powerful approach in many computers' visual activities such as image classification, object detection, and segmentations. Leveraging this technology for the image forgery detection has a lot of potential due its capability to and automatically learn and extract the intended patterns from the data. Leveraging this in technology for the forgery detection has a lot of potential due to its capabilities to automatically learn and extract ingredient patterns from the data. This research aims to explore the application of a machine learning specifically constructing a normalization constraining neutral networks. In the territories of image forgery detection, CNNs are appropriate for image related tasks as they can efficiently learn characteristics from the hierarchy raw pixels data and effectively capture local and global patterns available in the image. The primary this study objective is to create a robust and accurate forgery or distinguishable detecting system between the authenticated and manipulated images. To achieve this, we will collect and curate a diverse dataset containing both genuine and forged images. This dataset will be employed to instruct the CNN model to recognize the characteristical patterns connected to various types of image forgery detections. So, objectives of image forgery detection using machine learning are dataset collection, processing, feature extraction, model design, model training, model evaluation, comparative analysis, real world application, advertisational robustness, generalization, scalability. First, dataset. Dataset gathers a diverse and comprehensive dataset containing a sophisticated number of authentic image, and several different manipulation image representing common forgery techniques. This dataset will be served as a foundation for training and evaluating a computer learning model. Pre-processing implement a pre-processing technique to standardize and raise the standard of the dataset. This may include resizing image to consistent resolutions, normalization pixels, values, and applying data argumentations to increase size of the dataset and diversity. Feature extraction utilize CNNs for automated conventional neutral networks learner and extracts the features from the image. CNNs are adapt at capturing local and global pattern, making them well suited for image related tasks. Model designs where they develop a forgery reduction model depending upon CNN architecture, determine the amount of layers, kernel size, activation functions, and other hyper parameters that best suit the specific forgery detection task. Model training the CNN as a simultaneous of a pre-processed dataset, employed appropriate loss functions, and optimize algorithms so as to effectively develop the model and on the forgery detection task. Model evaluation assessment of the effectiveness of the raised model on a separate testing dataset. Calculate matrix as accurate accuracy, recalls, and F1 scores to access the model's ability to distinguish between genuine and manipulated images. The comparative analysis conduct a comparative analysis with the state of the forgery detection method to comprehend the various and defects of the proposed machine learning approach. Real world application explores the particular practical application digital detection of image forgery learning. How may this technology be used for digital forensics, verifying and authenticity of the virtual content, com- combating misinformation and copyright protection. Adversarial robustness investigate the model's resilience against adversarial attacks, which attempt to fool the forgery detection system by introducing subtle in modification to the forged images. Generalization ensures assure that the trained model generalizes well to unseen data and several different kinds of forgeries, address potential issues related to overfitting or bias. Scalability access the scalability amount of the suggested machine learning approach to handle large scale data set and real time detection requirements. Then this future direction. Mention any possible areas for growth and future research in the image machine based forgery detection learning. Identify possible enhancement to models, architecture, data collection, data strategies, and algorithm advancements. By achieving this objective, the research aims to provide anything to field of image forensic and provide an effective and dependable tool for spotting fake images, thereby enhancing trust in the digital visual content. Next, methodology where the assign method is used. As shown in the below figure, assign method works in iteration of a small box which consists of requirements where analysis and designs execution takes place, and then requirements, and then next iteration starts, which at lastly results in a consolidation and releases, which is the final report. It's faster and easier than waterfall model, where verification occurs first, which allow developer to promote adaptive planning, evolutionary development, delivery. These are some of the agile methods. Chapter 2, which consists of literature survey and existing system. Existing system is the literature survey reveals that image fraud detection. The use of machine learning has drew significant attention in recent years. Researchers have looked into several methods and techniques to address this challenging problem. Below in an analysis of some of the existing systems found in the literature. Image processing using conventional neural network forgery detection, where several researchers have used this technique with the success. CNNs for image forgery detection. CNNs have proven that their capacity to automatically learn and take complicated characteristics out of photos, making them well suited for this task. This model attains a high level of precision in detecting common forgery techniques such as copy move, splicing, and retouching. Transferring learning, where pre-trained CNNs are fine turned on forgery detection datasets, has also been explored to improve the performances. Feature-based approaches, which is some researchers has focused on handcraft feature-based approaches for forgery detections, where the local binary patterns, for example LBP, color historics, histograms, and valid transformations are extracted, and when combined with the conventional machine learning or support vector machine, which is SVM, or random forests. While these methods can be effective in certain scenarios, they often struggle to capture suitable and complex forgery patterns compared to deep learning methods. Unassembling the method. Several studies have proposed unassemble based approaches or rise in stability of a forgery detection system. These unassembles are combine the output of multiple base models, CNNs, or traditional classifiers to give the final decisions. This helps in reducing false positive and enhancing overall accuracy. Generic adversarial networks, GANs have also been used for picture analysis, forgery detections. These model consist includes a generator and a discriminator, with where the generator tries to create forgeries and the discriminator aims to differentiate among actual and forged images. This conceptual educational process can help in detecting subtle forgeries and dealing with the adversarial attacks. Domain specific datasets. Researchers have highlighted how significant using domain specified datasets for training forgery detection model. Datasets containing various types of forgery and authenticity images from the specific domains and advertising attack and defense. According to studies, a fraud detection model, particularly those built on deep learning, are susceptible to adversarial attack. Real time detection. A few words have emerged the importance of a real-time image forgery detection, especially in scenarios like social media platforms where the detection needs to be fast and effective. Optimization technique and model compressing have been explored to achieve real-time capabilities without sacrificing accuracy. Proposed system. In the proposed system utilized for the identification of fake image machine learning is presented. Here it is a potential literature survey analysis of a system where it consists of a novelty and contribution, methodology and model architecture, dataset and evolutional matrix, performance comprisations, adversarial robustness, real world applicabilities, and limitation and further directions. Feasibility study. A feasibility study, while detecting a picture, forensic machine learning involves assessing the particularly valuable viability and potential success. The suggested project. Here are the key aspects of consider in the feasibility study. Technical feasibility, where the evaluate whether the required technology tools and expertise for developing a machine learning based forgery detection system are available and accessible. Dataset availability, where it consists of examining the availability and quality of the dataset containing both authentic and manipulated images for training and evaluation. High quality pictures and diverse dataset are crucially for building precise and reliable forgery detection models. Algorithm selections. Investigate most appropriate machine learning algorithm and architecture for image forgery detection, and evaluate the advantage and limitation of different approaches like CNNs, GANs, unassembler methods, and select the ones most appropriate for the specific forgery detections. Performance metric consists of defining the evaluation matrix, which will be evaluated to determine how well the image forgery detection system. Common measures such as recall, accuracy, and precision, F1 square, and area under the ROC, which means receiver operating characteristic. Next, adversarial, robust, and computational resources, ethical, and legal consideration, where it consists of examine any ethical and legal implementations for the forgery detection system, especially concerning data privacy, user consent, and problem with the copyright. Real world applicabilities. Assess the potential real world applications of a forgery detection system. Consider where it is possible. Time and cost constraint estimates the overall time and expenses required for the development, training, and the deployment of the forgery detection system. Tools and techniques where we used are PHP is a server-side scripting language designed for the web development. PHP is a hypertext processing feature of a YII, where model via view control are consisting of business logic flow control, and web designers are working differently. Changes do not affect other parts, and changes are responded quickly to the users. CSS, cascading style system, were used for advanced design of the web page, used with Bootstrap, used with HTML tags and inline external and internals. Ajax, which is an asynchronous JavaScript used to elaborate the JavaScript. WAMP. WAMP is a server approach to run MySQL and PHP. It used CGI, which means Common Gateway Interface. jQuery includes the following features. It is a user friendly, it is interactable, it uses DOM, event effects and animations, Ajax, JSON, parsing and extensibilities. MySQL features which writes in a C and C++, tested in all the compilers, platforms, dependency in a less is less, uses graphical queries. Hardware and software requirement. Hardware requirements consist of a server where server sides machines are processor, which is a Xeon process server, basic server class machine or Intel Premium 3, RAM of 4 GB, hard disk of 500 GB, monitor of 15 colors. Hardware requirement of client machine are Pentium 5 GHz, 1 GB RAM, 15 colors and 500 MB. For software requirements are PHP as I said above, CSS, jQuery, NumPy, Pandas, Python, Apache, MySQL, Rapid, PHP and Windows. It can be operated on Windows XP 7 and 10 and Linux operating systems. Software specification, which is consisting of purpose, scope, functional requirements and non-functional requirements. Purpose of this development is the image forgery employing machine learning for detecting technique. The system will automatically analyze the digital image and identify the potential forgeries, thereby assuring the authenticity, integrity, and visual content. Scope. The image forgery detection system will be designed to recognize this distinct sort of forgeries, including copy move, splicing, retouching, and other common manipulations. The system will primarily be used for digital forensics, social media for verification, copywriting potentials, and combating misinformation. Functional requirement consists of processing, feature extractions, image inputs, training and model optimization for forgery detection, adversarial robust, and non-functional requires performance, scalability, usability, etc. Hardware requirements is specifying running on the bare minimum of hardware. The forgery detection systems include CPUs, GPUs specifications. Data availability are the systems efficiently, highly relies the having access to diverse and high quality labels dataset. Effort should be made to create a appropriate dataset if existing ones insufficient. User interface consists of input interface and output interface, where it is allowing the user to upload the image for the forgery detection and display the image preview and provide options for batch processing. And output is displays the result for the forgery detection and including the location of detected forgery and confidence scores. Provide options for downloading or exporting the results. This software requirement specifies SRS requirement specifies the server as a guideline for the development team to build the image forgery detection system. It outlines the functional and non-functional requirements. The chapter 4, as said, the system design. System design consists of a system predictive where control it gives a processor, which is an input coming from the process, giving to the processor, and goes to the output. The output coming back is feedback and put as an input, which is ended with the boundaries and interfaces. Categories of information is as following table. Context diagram. The context diagram consists of a centralized server which has a local servers and clients with it. This figure shows the structure of this system. There is a centralized server as well as n number of local servers. An entire is made of a local system, and this is updated on the local server and then on the centralized server when there is a stable internet connections. When there is no internet connection for some time and a transaction is made on the local server, a flag bit is set to indicate that the centralized server has not received an update with the recorder, which is on the local server. When the connections resumes, these records get update on the centralized server and the flag bit is unset. Chapter 5. Delightful design means the design which is diagrammatically explained here. The use case diagram completes the user design of machine based forgery detection learning, where registration, login, provide product, my product, ranking product, provide reviews and rate product, analyzes behavior detection, fraud reviews, and elimination fake reviews, and predicting user interest. Architecture overview, which consists of data processing, CNN based extractions, model training, forgery detections, adversational robustness, and data flow diagram. These are some of the symbols of data flow diagram which are used here. This is the data flow diagram. ER diagram consists of the entity relationship diagram, which displays the relations in the entities. This is the entity relation diagram with the OpenCV, where the vision sensors are used and customized smart object detections are used. Implementation. This is the code which is used in the implementation, where these are the auxiliaries used, which consist of user page, where the upload photos are and some of the options are given. Then after uploading for view, the photo uploaded is shown in the figure 2 of the implementation, and then the result. This picture is original picture, that's why it is showing the clone detection, where there is no clone present. In this interesting part is location page, where from where the image is being detected or checked for the forgery, the location of that person can be seen here. This is the quantized table, which shows the matrices formed by the fake image detection and shows the quantized table. Software testing. Software testing consists of functional testing, non-functional testing, regression testing, and retesting. Types of testings, and then we use here black box testing, and white box testing. Reason to apply this testing technique is the testing on the white box is internal structure design and code testing of software system. The code is open to tester during this kind of testing. It means its main objective are boot security, enhance design and usability, and confirm the system's input and output softwares. The acronyms open box, clear box, and structural and transparent code based and glass box testing are also used to describe testing in a while white box developers often handle it. This is the test case carried out where a login portal which displays and logins the pages for admin and users. The login page must use the registered users, register users logins and status is pass. Second, the initial page. Initial page consists of a clicker to the provided menu and all the previews detail displayed. All complaints button is pushed. All the details it will retrieve from the database, which is the value result, and status is passed. Third, image processing detected for forgery. After processing of the image, detection of the forgery is done, and then outcome is generated, which is the final result of all the details that will be kept in the database are status passed. Conclusion: image forgery detection and machine learning analysis has emerged as a valuable and effective tool in combating the increasing prevalence of the image manipulation and forgery. In this conclusion, we summarize the key insight benefits as well as employing machine learning for image forgery detection and analysis, where the accurate forgery detection is taken place, robustness is taken place, real-time descriptions, wide applicabilities, automations, deep analysis, large-scale image analysis, multiple model analysis, generalizations, and the authentical considerations are taken place. Further directions are as the field of image forgery detection and analysis using machine learning continues to evolve. Several areas warrants further explorations. Adversarial attacks, adversarial explainables, deep fake detections, end-to-end forgery localizations, real-world developments, etc. Future enhancement has a image forgery detection and analysis. The use of machine learning is an evolving field with numerous opportunities and further enhancement as the technology continues to advance. Here are some such areas where the for improvement and development improves the adversarial robustness and deep fake detections, end-to-end forgery localizations, explainable AI forgery detections, assembling learning, argumentation of the data transfer learning, and multimodal analysis, real-time detections, high resolutions, etc. Thank you.